These are the answers to worksheet 7.2. The first one here wants us to find this area of R by putting it in terms of x. So the top equation here is 2x. This bottom equation is x squared. So if we do top minus bottom, we're going to integrate that in terms of x, so that'll be from 0 to 2, and we'll have the dx on there. So each of those rectangles have a height of top minus bottom 2x minus x squared, with the dx being the width. Now if we were to integrate this by hand, we get x squared minus x cubed over 3. We're going to do that from 0 to 2, and this will give us 4 minus 8/3 minus 0. So when you do that, you'll get 4/3 for your answer. Okay. Now, part B says do the same thing, but now put this in terms of y. So this, if I were to do that, instead of having this equation be 2x, what I would do now is have this be y divided by 2. So take your equation and basically get x by itself. That y divided by 2 now would represent this length right here. Okay. And then I would change this into square root of y, and that would represent this length. The square root of y is the longer of the two, so we're going to have the long one, the right, minus the left, and we'll be integrating that from, in terms of y, 0 to 4. And then a dy on that. Okay, now again, if we were to do this by hand, this would be y to the 3/2 over 3/2 minus y squared over 4, the 1/2, and then another 1/2. You can kind of work that out. All right, we're doing that from 0 to 4. So I put 4 in here. Square root of 4 is 2. 2 to the third power is 8. 8 times what would be 2/3 would give us 16/3. Minus, put the 4 in here. 4 divided by 4 is 4. And so we're going to get 4 on this, and if that you made 16/3 minus 12/3, you'd get 4/3. Same exact areas that we had up there, one in terms of x and one in terms of y. Right. Then we get to C, and C says, can you find the volume if we were to spin this around the x-axis? So if we spin it around the x-axis, what we want to consider is what this here would be. So that would be the 2x. That would be the radius of the outermost circle. So if I go pi times 2x squared from 0 to 2, all right, that would give me the volume as if the whole thing was going, but we're not going to do the whole thing. We're going to take a piece out, and the piece that we're taking out has a radius of of x squared. So we'll be taking x squared out of that. All right, and then dx. So this is our big radius squared minus little radius squared, pi times that. If we work this out by hand, it would be, this would be 4x squared, this would be x to the 4th. We would get 4x cubed over 3 minus x to the 5th over 5, doing that from 0 to 2 with a pi out in front. Okay, and then if you were to put 2 in there, we'll get 16/2, which is 8, minus, put the 2 in here, 32/5. All right, and we will end up with 40/5 minus radius, so we get 8/5 pi as our volume there. All right. Find the volume if we were to spin it around the line y equals 7. All right, so now if I were to put a line y equals 7, say up here, and I were to look at the big radius is this measure right here. That measure is going to be 7 minus the x squared that we don't want. That's our big radius. And then our little radius, the part that we're going to be taking away, is this one. That's going to be the full length 7 minus 2x, the piece we don't want. Okay. And we'll integrate that from 0 to 2 with the dx. So there's our big radius, pi times big radius squared minus little radius squared. That one we're not going to do by hand. Put it on a calculator and see what you get from there. Okay. All right, then this one says find the volume if the solid's formed when you rotate it around the y equal -2. So if we put it around -2, now the big radius is from here down, so it's going to be 2x plus 2 more. And the part we don't want is going to be this x squared plus 2 more. That's our little radius. So we'll integrate that from 0 to 2. So pi from 0 to 2 big radius squared minus little radius squared dx. And that would give you the volume if we spun it around there.